In this lesson, we're going to take a look at solutions of inequalities. First of all, let's review what inequalities look like when they are graphed on a number line. So if I have x is equal to 5, what that means is that I would have, in every case, x can only be 5. So we would show that by putting a solid dot on the 5. Now if I wanted to represent x as less than or equal to 5, I would have 5, so it includes the 5, and it includes everything that is less than 5. So you have 4, 3, 2, 1, 0, and all the negative numbers. It's going to go on and on forever to the going negative. So it's going to include 5, and it's also going to include anything that is less than 5. Remember then, if I have greater than or equal to 5, it's also solid, meaning it's also going to be including the 5 and everything that is bigger than 5. So I'd have my 6, 7, 8, and going on and on forever, going more positive. So now if I were to graph the x's less than 5, remember 5 is not less than 5, so that we show that it's not equal to 5, that it doesn't include the 5, but it includes everything that is less than that 5, we're going to put an open dot. So that means that it's not equal to 5, but it's everything that's less than 5. And then to show that it's greater than 5, again, it's not going to include the 5 because 5 is not greater than 5, but it's going to include everything that is greater. So we show it by having an open dot. So now let's go ahead and determine the truth of an inequality graphed on a number line. So can x be equal to 3? All right, so I have this inequality right here, which is x is greater than or equal to 4. So that means it's going to include 4 and anything greater than that. So can x be 3? Is 3 greater than or equal to 4? No, x is not greater than or equal to 4, so we're going to say that this is not a solution. So x cannot be 3. I can have 4, 5, 6, 7, anything that's greater than or equal to 4, but I cannot have something that's going to be a number like 3. All right, so our next one, can x be equal to negative 3? So let's take a look at our graph. What we have graphed here is we have x is less than negative 3. All right, so that means that it's going to include anything that is less than negative 3, but it does not include the negative 3. So let's plug in this negative 3. We're going to say is negative 3 less than negative 3. If I had less than or equal to, it would be a solution, but I don't have that. I have just less than. Negative 3 is not less than negative 3, so this is not a solution. All right, for our next one, we have x is greater than negative 2. All right, because it's got an open dot, it's not equal to, it's just greater than. All right, so let's take our 10. Is 10 greater than negative 2? Yes, and even though you don't see it here on the graph, we know that 10 is going to keep going in that positive direction. 10 is greater than negative 2, so this is a solution. All right, our next one. We have on our graph, we have x is less than or equal to 4. So that means that x can be 4, it can be anything that is less than 4. So is negative 12 less than or equal to 4? Yes, negative 12 is less than 4, so it is going to be a solution. All right, so in example number 2, we're going to examine the truth of an inequality. We're looking at what they look like as inequalities, not on a graph. So we're saying that x is equal to 3. So I'm going to take this 3 and I'm going to plug it in where I see the x. And then I'll simplify. So let's go ahead and we're going to have 4 times, we're saying x is 3, plus 5, is that greater than 25? So I have 12 plus 5 is greater than 25, and is 17 greater than 25? No, since 17 is not greater than 25, x cannot be 3. It is not a solution. All right, our next one, we have x is equal to -3, and we have x squared is greater than or equal to 9. Remember that when you have a variable that is assigned a negative number, bring it in with the parentheses on it, because that's different than if it didn't have the parentheses. And anytime you have a variable assigned to a negative number, you have to bring that parentheses in. So greater than or equal to 9. So -3 squared, it's -3 times -3 is 9 greater than or equal to 9. Yeah, 9 is not greater than, but it is equal to. And since it fulfills that equal to part, we're going to say yes, it is a solution, because x can be anything that is greater than or equal to. So let's see here, a solution. All right, for our next two examples, we have points. So these are this is an x and this is a y. So we're just going to plug those in and then simplify from there. So let's take a look. I have 3 times 4 plus 5 times 2, and I want to know, is that greater than 22? All right, so I have 12 plus 10, is that greater than 22? So is 22 greater than 22? Well, because 22 is not greater than 22, this is going to be not a solution. If I have the equal sign there, yes, but I do not. All right, in our last example here, I have 3, 4. So let's go ahead and assign our x and our y. And so I have 4 is less than or equal to 2 times 3 plus 5. All right, is 4 less than or equal to 6 plus 5? 4 less than or equal to 11? Since 4 is less than 11, we're going to say that this is a solution. So in this lesson, we took a look at how to determine the truth of inequalities.